Hi everyone. So this is question 9, story sheet 2. So I'm going to solve this question, and probably after this I may also start complex numbers. So when you are solving such type of questions, first of all you need to identify the topic where these questions come from. So when you look at these questions, these are compound angles, and if you want to study compound angles in details, you can use this book, and I can recommend you to use this book. Yeah, this one, Additional Mathematics 6th edition, Pure and Applied, by J.F. Tabart. It's a very important book. It has summarized trigonometry very well. You can't go wrong if you understand this book. You'll be able to answer all questions on trigonometry. Even sketching of graphs, you'll find it in that same book. So if you need it, you can inbox me. I'll send it to you. So we can now start. So the first question here is cos. This cos, open brackets, tan inverse of 7 over 24 minus sine inverse of 4 over 25. So in this question, the first thing you need to identify is which equation am I going to use on compound angles. So let's go and check the equations. This is cos, and the operation that we have here on the middle is negative subtraction. So these are compound angles. These are compound angles equations. So when you look at these equations, you discover that we had cos this side, and then here on the middle there was a minus. So probably this is the equation that we're going to use, which is cos A cos B plus sine A sine B. So this is the equation that we're going to use. Okay, let's go back. So now, having known the equation that we're going to use, let's first write it here. So you guys, you have to master these equations. You don't you are not going to be given these equations in the exam. You just have to know them by heart. So for cos, and there is a minus here, the simplest way you can know it is that for all cos equations, let me just do this. Okay. Yeah, for all cos equations, just know that the equation is like this: cos, let me use alpha and beta. Cos alpha, cos alpha minus beta is equal to. So for cos, always, actually what you should understand is that always the trig ratio that is this side is the one that will start here. So since we have cos this side, we're going to start with cos here. Cos alpha, then cos beta. For cos, you always start with two coses, and then and then the signs will follow afterwards. And then for cos again, if there is a minus here, there will be a plus here. If there is a minus here as an operation, this side there will be a plus. And then this side you have only sine, so this will be sine alpha, this will be sine alpha, sine beta. Yes, so this will be cos alpha cos beta plus sine alpha sine beta. Now, are you telling me that we're going to be putting the whole tan inverse here on cos alpha? No. Okay, let's assume this tan inverse of 7 over 25 is equal to alpha, and then sine inverse of 4 over 5 is equal to beta. So we're going to say alpha is equal to the tan inverse of 7 over 24. So this is our alpha, and then our beta we've said is going to be, our beta will be equal to sine inverse, it's going to be sine inverse of 4 over 5. So this is going to be our beta. So this is going to be our beta. Yes, now we'll move on. So this is going to be our beta. Now how can we find now cos alpha from tan inverse of that? So remember SOHCAHTOA, we're going to go back to SOHCAHTOA. We know that when you're finding x in SOHCAHTOA using tan, you say tan inverse of, okay, when you're finding x, tan x is equal to opposite over adjacent. So when you're finding tan, when you're finding x, it means that you're going to have, x is equal to tan inverse of the opposite over the adjacent. Let's try to do this. Let me see if it's going to work. Okay. So that's failed. Okay, let me just explain from this same side. So we're saying if you want to find cos x, you use adjacent and hypotenuse. This is according to SOHCAHTOA. If you want to find sine x, the sine of this angle, you need to use opposite and the hypotenuse, the opposite and the hypotenuse there. So same applies to this. Same applies to what we are doing here in this question. We are going to draw a simple triangle. We're going to draw a simple triangle under tan. So this is going to be our alpha. So meaning for us to find the alpha, we need to using tan. For us to find alpha using tan, we said for tan we use the opposite, SOHCAHTOA, opposite over adjacent. We use the opposite over adjacent. So tan, we use the opposite over adjacent, which implies that this 7 is our opposite over this 24, which is our adjacent. So the opposite to this alpha angle here is 7. So I'm going to write 7 there. And then the adjacent to this angle is 24. And when you use Pythagoras to find the hypotenuse this side, you discover that your hypotenuse is going to be 25. Okay. So this is what we are going to do. So from here, I think we can find our cos alpha and our sine alpha. So the reason why I'm saying we can find our cos alpha and our sine alpha and sine beta is because what we need here in this equation is not tan alpha or tan beta. We need cos alpha and cos beta and sine alpha and sine beta. So let's move on to this question again. I mean to finding beta. So beta, we are using sine. Remember sine, according to SOHCAHTOA, sine we use the opposite and the hypotenuse. So meaning, so sine is equal to, sine x is equal to opposite over hypotenuse. So meaning, same applies to this part. So if this is our beta, our sine alpha will be the opposite, which is going to be our 4, over 5, which is the hypotenuse. 5, the opposite over hypotenuse. And then meaning this side, if you use Pythagoras, you discover that 5 squared minus 4 squared, you find your answer to be 9. And then the square root of 9, you discover that your answer will be 3. when you use Pythagoras. So I think we can now even plug in our values in this equation. So I'll write this. I'll write here cos alpha cos alpha minus beta is equal to, my cos alpha will be what? I'll go where there is this angle alpha. So cos alpha, we know to say cos alpha, cos alpha. So is the, so is adjacent over hypotenuse. So katoa ka is adjacent over hypotenuse. So for cos alpha, I'll go where there is my adjacent. Adjacent is 24. I'll write 24 there. Over my hypotenuse is 25. I'll write my 25 there. Then I'll put them in brackets like that. And then I open another set of brackets. I'll go on to find cos beta. Cos beta, I'll go where there is this angle beta, and then I'll locate where my cos beta is. So cos beta will be, again we're still using adjacent and hypotenuse. So we're still using adjacent and hypotenuse. So adjacent here will be 3 over my hypotenuse there will be 5. And then I'll put a plus, this plus here, I'll put it there. And then I'll open another set of brackets. Let me also find sine alpha. Sine alpha, we go back again where there is this angle alpha, and then we find sine. Sine, so katoa. So sine is opposite over hypotenuse. So sine is opposite over hypotenuse. So we continue like that. So my opposite there on alpha is 7 over my hypotenuse there is 25. I'll close the brackets, open another set of brackets, and then I'll go on my beta. Sine beta is sine beta. So I'll open another set of brackets on sine beta, which I've done here. Then sine is opposite, so my opposite is 4 over my hypotenuse, which is 5. So now I think from here it's even now easier. We just have to do fractions here. We all know how to multiply, divide, and add fractions. So when you multiply 24 times 3, you discover that your answer will be 72. And then over 25 times 5 there, this is 125. And then you add 7 times 4 is 28. And then 25 times 5 is 125. It's 125. Then equals. So since we have the same denominators here, it's just the same as just adding directly the numerators there. So when you add the numerators, you discover that your answer will be 100 there. 72 plus 25, you get your answer to be 100, and then over 125. So after doing this, you can now even find your answer. Your final answer will be, when you reduce this is just the same as 4 over 5. When you divide everything by 25, you discover that your answer will be 4 over 5. So cos alpha minus cos beta, cos alpha minus beta will give us 4 over 25. So this is our final answer for the first part. So this is our final answer for the first part, this question. I think we can even do quickly the second part. Hope you've understood. So these are simple questions. Just need to understand what they need you or what they want you to do on the question. Okay, let me just try to move them. Sloped. Okay, let me just leave them like this. Alright, we continue. So the second question here is saying sine tan inverse of that plus cosine. Let me just do it on this other part. All right. So the second question here, B, is saying, I will just cut the board like this. Okay, the second question here is saying sine tan inverse of that. We do the same. So first of all, we check which trig ratio are we going to use, or which equation on compound angles are we going to use. So the equation on compound angles, we've seen that there we are using sine. Now let's check the operation there. Is it plus or minus? So the operation there is minus. So this is minus. And for sine, when there is a minus here, there is also a minus here. So let me also show you the simplest way of how you can master this. Look at here, sine. For sine, okay, let me just do this. Okay, for sine, look at this, sine. For sine, you can okay, sine. Okay, let me not even write, I'll just explain. For sine, this sine can also, this S at the first can also stand for same. Sine, same. So meaning if you are using plus here, you should use the same plus there when you are writing it. If you're using minus here on sine, you use the same minus to put on as an operation there between. And then for cos, just know that it's the opposite of the same, meaning it's the opposite of sine. It will be the opposite of sine, which is if there is a plus here, you put a minus there. Hope we're together. So for sine, just know that again to say, since the angles are different, you will be using sine A cos B and plus cos A sine B. But the sign there is supposed to remain the same. So let's move on and see what we can do. So sine this. So of course I'm going to say let alpha. So I'm going to say let alpha be equal to the tan inverse of 3/4. So alpha is equal to the tan inverse of 3/4, and then beta will be equal to the cos inverse of, so beta will be equal to the cos inverse of 24/25. So this is 24 there. I've just made a mistake. Yeah, this is supposed to be 24. So this is 24/25, cos inverse of that. So we're using sine here. Sine, we know to say the compound equation for sine alpha minus beta, sine alpha minus beta is equal to the first. Remember what I said there? I said if you have a trig ratio here as sine, meaning sine is supposed to start first here. If you have the trig ratio here as cos, cos is supposed to start. So if I have, so since here I have sine, I'm going to start with sine alpha. I'm going to start with sine alpha, then followed by cos beta, cos beta. And then since sine, we are dealing with sine, so meaning I'm dealing with same. So sine, same. You can master this, sine theta, same. So since I'm dealing with sine, my sine here will be the same as here. And then I'll start, this time around, instead of starting with sine alpha, I'm going to start with cos alpha, or which is just the same as starting with sine beta. Sine beta, I'll just swap the angles, sine beta, and then I'll say cos alpha. So this is how you do these equations. They are very simple and straightforward. And then we move on, we draw triangles. So I'll first draw a triangle for alpha there. So the triangle for alpha, so look at this, we have 3 over 4. And then tan, we know that tan, when you're dealing with tan, toa, so katoa. So when you're dealing with tan, we're simply dealing with opposite and the adjacent. So this 3 is our opposite and this 4 is our adjacent. So 3 is supposed to be this side, and then our 4 is supposed to be here. And then when you use your Pythagoras here properly, you discover that your hypotenuse will be 5. And then we also find the triangle for our beta there. So our beta, if our beta is here, so if our beta is there, we're dealing with cos in this case, so ka, so katoa, ka. So meaning we're dealing with adjacent and hypotenuse. So katoa, meaning adjacent over hypotenuse. So what is our adjacent there? Our adjacent is 24. So meaning this part is 24, and then this part is 25. And then when you do your Pythagoras, you discover that your opposite there will be 7. So from there, I think we can even start putting in the values. So our sine alpha will be what? Sine alpha, let me write sine alpha there, sine alpha, let me just write it properly, sine alpha minus beta. So sine alpha minus beta is nothing but sine alpha cos beta minus sine beta cos alpha. So what is my sine alpha? Sine alpha, I'll go where there's this angle alpha, and then I'll find my sine. Sine is simply so, meaning opposite over hypotenuse, according to SOHCAHTOA. So sine is opposite over hypotenuse. What is my opposite to this? The opposite to the angle is 3, and then my hypotenuse there is 5. Then I'll write it there, and then open brackets. I'll move on to my cos beta. I'll go where there's the angle beta there, and then I'll try to check cos beta. Beta meaning is adjacent and hypotenuse. Then what is my adjacent? My adjacent is 24. My adjacent is 24 over, what is my hypotenuse? My hypotenuse is 25. Yeah, this is 25, and then I'll write minus there. This minus is the one that I've written here, and then open brackets. we move on to sine beta. Sine beta, we are still dealing with sine which is opposite and hypotenuse, so we go where there's this angle beta. Angle beta, now we're dealing with sine, so meaning it will be opposite. Which one is our opposite? 7. So 7 is our opposite over, what is our hypotenuse? Our hypotenuse is 25, right? 25 like that. Then we close brackets, open brackets again, and then we go and find sine alpha, cos alpha. So cos alpha, we're dealing with cos. Cos is adjacent over hypotenuse. Then we go where there is this angle alpha. This angle alpha, our adjacent to this angle is 4 over, and then the hypotenuse to this angle is 5. So now we can go on to find the solution, which is now even easier. So what we do is 3 times 24, your answer is 72, over 5 times 25, you find your answer to be 125, and then minus 7 times 4, your answer will be 28, then over 5 times 25, your answer will be 125. And then when you subtract these, you discover that your answer will be nothing but 44. Your answer will be 44 over, so your answer will be 44 over 125. This will be your answer. So thank you very much for watching the video. These are the answers for question, this is question 9. These are the answers for question 9. Thank you very much for watching the video, and don't forget to subscribe, and please send your questions. Those that have questions, you can send them via WhatsApp to this line, and I'll be there to answer them and post them on this channel. Thank you very much for watching. Subscribe now.